Hello again. Let's continue with week 12. In this video, we're going to talk about atmosphere of Earth and gas laws. I would like you to pause the video for a moment and think about these questions. What is atmosphere? What it does for us? What do you know about it? Pause the video. Okay, I hope you thought about the questions. On the screen right now, you see some possible answers, and there are some more. Google the facts about atmosphere on Earth and on other planets to learn more. But what I can assure you that atmosphere is a very important part of our life. It plays a huge role in keeping all living things on Earth safe. I would like you to think about this question and also to think about atmospheric pressure and think about the magnitude of it or the value of it. How much is the atmospheric pressure? And why, if there is a pressure on glass windows, and we know that glass is fragile, why they don't break? We're going to continue talking about gas laws, and we'll talk about one gas law in particular in a second. But I would like you to think about this experiment, or actually I suggest that you try it at home. This experiment will provide you with the evidence and will help you to think about the gas laws. In general, gas laws are the laws that connect the pressure of gas, the volume of gas, and the temperature of gas. And this simple experiment is a fun way to explore the laws. We're going to talk in particular about Boyle's law. The Boyle's law tells us that if the density of a gas increases, the pressure of the gas increases as well. Or opposite is true. If the density of a gas decreases, the pressure of the gas decreases as well. There are many applications of Boyle's laws. Here you see one of them. Another law or principle I would like you to be aware of is Bernoulli's principle. It is a principle about fluid dynamics, about the motion of the fluid. And it tells you that the faster a fluid flows, the less pressure it has. One of the applications of Bernoulli principle is the invention of the airplane wing with a certain shape. And the shape is so that we have an area with low pressure on top of it, which means that the air flows faster on top of the wing and slower at the bottom of the wing. This way, we have the difference of pressure between the bottom and top of the wing, which is responsible for the upward lift force. Now I would like you to pause the video and think about the question that you see on the screen. So it's really important because this question summarizes what we've talked about, the fluids and the pressure in liquids. So please take a moment, think about the question, pause the video. Okay, so the answer to the previous question is the same force is required. So it doesn't matter what is the volume of the fluid or liquid on the other side of the hole if we have these three assumptions valid. What you need to remember that we can calculate force as pressure times area. We know that the area of the hole is the same. In terms of pressure in liquids, we talked before that pressure in liquids depends on density of the liquid, acceleration due to gravity, and the depth below the surface. In the question, all these three physics quantities were the same, it means that the pressure is the same, doesn't matter whether or not there is a lake or the ocean on the other side, and because the area was the same, the force required is the same as well. That's it for now. Take care.